Sugar is not just a product we add every day to tea, coffee, or desserts. It is one of the oldest and most influential ingredients in human history. The first mentions of sugarcane date back to India several thousand years ago. In Europe, sugar appeared through Arab traders during the Middle Ages, and for a long time was considered a luxury available only to the nobility. But with the development of technology, sugar ceased to be a rarity and became an everyday product familiar to everyone. Today, the global sugar industry is valued at billions of dollars, and sugar factories are high-tech enterprises where tradition and innovation meet. But how does an ordinary stalk of cane or root of beet turn into white crystals? Let's find out. Sugar can be produced from two main sources, sugarcane and sugar beet. Cane grows in tropical and subtropical regions. Brazil, India, and Thailand are home to the largest plantations. Beets thrive in temperate climates. France, Germany, Russia, and the USA are leaders in their cultivation. Despite their different origins, the final product is the same, sucrose. The secret is that both cane and beets contain about 15 to 20% sugar. The main task of the factory is to carefully extract it and refine it into the purest crystals. The process of sugar production begins long before the factory. Sugarcane is cut by special harvesters, or manually, depending on the region. The stalks, several meters long, are sent for processing immediately, as cane quickly loses its juice and can spoil. Beets are harvested with mechanized machines, cleaned of soil and leaves, and loaded into huge trucks. It is crucial that delivery to the factory is as fast as possible. Otherwise, the sugar content in the raw material decreases, reducing the yield of the final product. At the factory, everything begins with cleaning. Sugarcane is loaded onto conveyors, where powerful water jets and special drums remove dirt, leaves, and stones. Beets are first washed in massive drums with running water and then shredded. At this stage, the foundation of the future sugar quality is laid. The cleaner the raw material, the better the final product. It is important to understand that every extra particle of soil or debris can affect the color and taste of sugar. Now the raw material must be squeezed. For cane, its stalks pass through a series of powerful rollers and crushers that press out the sweet juice. The remaining pulp, called bagasse, is not discarded. It is used as fuel for the factory's boilers, or as raw material for paper and biofuels. For beets, the process is slightly different. They are cut into thin slices and placed into fusion tanks, where hot water gradually washes out the sugar. The result is a sweet juice, the basis for future sugar, though still far from its familiar form. Juice from cane or beets contains not only sugar, but also many impurities, fibers, proteins, and organic substances. To turn the murky liquid into a clear syrup, several methods are used. One of the most common is adding lime milk and sulfur dioxide. These substances help precipitate unwanted impurities, regulate acidity, and eliminate microorganisms. Then the juice goes into huge settling tanks and filters. Gradually, the liquid becomes light and transparent, ready for the next stage, concentration. To turn liquid juice into crystals, excess water must be removed. This is done using special evaporators. In them, the juice is heated in several stages under reduced pressure, which allows water to be removed without destroying the sugar. As a result, the sugar concentration in the solution rises from 15% to over 60%. The output is a thick, sweet syrup that already resembles caramel base. This syrup is the heart of future sugar, and now the most fascinating stage begins. The syrup is heated and brought to a supersaturated state, after which tiny sugar crystals, called seed crystals, are added. They become the centers around which new crystals form. Gradually, The thick mass turns into a mixture of syrup and solid granules, called massicute. This process requires perfect precision. Temperature, pressure, and mixing speed must all be carefully controlled. It is here that the familiar white crystalline sugar we know is born. When the massicute is ready, it must be separated into sugar crystals and residual syrup. For this, centrifuges are used, huge drums spinning at incredible speed. Under the force of centrifugal motion, sugar crystals remain on the walls, while the syrup, known as molasses, is drained through special outlets. Molasses itself is valuable. It is used in alcohol production, animal feed, and even in the confectionery industry. But the main point is that centrifuges give birth to the familiar product: white sugar crystals, still moist and requiring further processing. After centrifugation, sugar still contains moisture. To prevent the crystals from clumping together and to ensure long storage, they are sent to drying units. These are massive drums or tunnels where warm air evenly blows over the granules. Gradually, the moisture level drops to 0.05%, practically complete dryness. At this stage, the crystals gain the free-flowing texture and ringing sound we recognize when sugar is poured into a sugar bowl. The dry sugar is sent to vibrating sieves, where it is separated by crystal size. Large granules go to refined sugar production, medium ones become standard packaged sugar, and the smallest turn into powdered sugar for confectionery use. Modern factories can adjust the process to produce exactly the crystal size the client needs. After all, sugar behaves differently in beverages, chocolate, or baked goods. And this is accounted for during sorting. Once sugar is ready, it is packaged. Some is filled into large 50-kilogram bags, some into 1-ton bulk bags, and some into small retail packets for supermarkets. Packaging must be airtight to protect the product from moisture and foreign odors. Sugar is stored in dry warehouses with stable microclimates. Thanks to its low moisture content and crystalline structure, sugar can be stored for years without losing its properties. Interestingly, almost nothing goes to waste in sugar production. Bagasse, left after cane pressing, is used to generate energy. Molasses is used in the food and alcohol industries. Even the dirty water from beet washing is purified and reused. Factories strive for maximum waste-free production, making the sugar industry a prime example of efficient resource use. Sugar is a mass-consumed product, which makes quality control a top priority. Factory laboratories check every stage, from raw material purity to the moisture content and color of finished sugar. Modern analytical methods can instantly detect impurities or deviations. If a batch does not meet standards, it is sent for reprocessing. Only perfectly white and pure crystals make it to packaging and the shelves. In addition to standard crystalline sugar, there is also refined sugar. It is made from large crystals that are dissolved again, filtered, and recrystallized to achieve maximum purity. This sugar is pressed into cubes and used where special cleanliness and presentation matter, in restaurants, hotels, and exports. Refined sugar is considered an elite variety with a unique market. Today, dozens of types of sugar exist. White crystalline sugar is the most common. Brown sugar retains part of the molasses, giving it a caramel-like flavor and aroma. Powdered sugar is used in baked goods and glazes. There is even liquid sugar syrup, widely used in beverages and liqueurs. Each category requires its own production technology, and factories can flexibly adapt to market demands. Sugar is a global product. Factories work with dozens of countries worldwide. Transport is carried out using containers, tankers, and trucks equipped with moisture protection systems. Export logistics require extreme precision. Sugar must arrive to customers in its original state, On international markets, consistency of quality is especially valued. It determines the reputation of the exporting country. The sugar industry provides millions of jobs and generates billions of dollars in revenue. In Brazil, sugarcane covers millions of hectares and is used not only for sugar, but also for ethanol, a biofuel. In Europe, sugar beet represents a significant part of agriculture. Sugar factories play a vital role in many regional economies, supporting farmers, transport, and processing industries. Each year, factories become increasingly automated. Robotic lines, sensors, and artificial intelligence systems save energy and water while boosting efficiency. At the same time, ecology is given special attention. Waste recycling, renewable energy use, and emission reduction. The sugar industry is gradually becoming more green, maintaining a balance between production and nature. A sugar crystal travels a long journey, from cane fields or beet farms to the packet in the store. We see only small white granules, but behind them lies the immense work of farmers, engineers, technologists, and workers. Sugar production is a remarkable union of agriculture, science, and industry. And perhaps that is why this product remains indispensable in human life, symbolizing the sweetness and energy without which our world would be hard to imagine.